Hello everyone, this is the continuation of our discussion for effective stress. So this time we're going to discuss in this video the stresses in saturated soil with upward and downward seepage. So let's start. In our previous discussion, we discussed the stresses in soil without seepage. So this time we're going to consider seepage, no? So class, if water is seeping, the effective stress at any point in a soil mass will differ from that in the static case. So iba class ang effective stress kapag walang seepage, iba rin yung nagiging effective stress kapag may seepage. So yung increase or decrease doon sa effective stress class, nakadepende siya doon sa direction ng seepage. So, take note of this class, no? Kapag yung seepage natin class ay pataas or upward, what happens class is that the effective stress decreases. Okay, on the other hand, if the seepage class is downward, okay, downward seepage, what happens to the effective stress is that it increases. Alright. Alright, let's begin with stresses in saturated soil with upward seepage. So here in figure 9.4a, it shows a layer of granular soil in a tank where upward seepage is caused by adding water through the bulb at the bottom of the tank. So the rate of water supply is kept constant. So meron tayo dito class tank, tapos ito yung granular soil, and then may tubig above the granular soil. Okay, tapos may valve tayo dito sa bottom part ng tank natin. At kapag inopen yung valve na yan, class, mag-enter yung tubig, which will cause upward seepage. No? So, class, kapag nag-attach tayo, class, ng mga piezometer, kung maalala mo, class, no, dun sa stresses in saturated soil without seepage, di ba, class, kapag naglagay tayo ng piezometer, yung pagtaas ng tubig dun sa mga piezometer natin, same level lang siya dun sa natin, level ng tubig dito. Tama? But in this case, class, kapag may upward seepage na class, no? So, class, kapag naglagay ka ng piezometer dyan, class, ang mangyayari dun sa tubig, dun sa piezometer, tataas siya. Okay, so yung magkakaroon ng pinakamataas na pagtaas, class, dun sa piezometer will be the piezometer na naka-attach pinakamalapit kung saan papasok yung tubig. In this case, dito papasok yung tubig. So, ang mangyayari dyan, class, etong piezometer na naka-attach na pinakamalapit sa pagpapasukan ng tubig, magkakaroon yan, class, ng pinakamataas na pagtaas ng tubig. Okay, so it will be above dun sa surface ng tubig dito, definitely. No? And also, class, kapag nag-attach ka din ng piezometer, class, let's say, in between, okay, in between this soil layer, let's say dito, sa point C, alright, so, class, ang tubig din dyan, class, ay tataas, pero hindi siya, a little lower siya, no? A little lower siya kesa dito, sa level ng tubig dito. Pero, mas mataas siya kesa dito. Tama, sa level na ito. Alright, ngayon, pagdating class dito sa point na to, ito na yung, kumbaga, uppermost point nung soil natin, class. No, class, kapag naglagay ka ng piezometer dyan, class, yung level ng tubig dyan, same level lang sa level ng tubig na to. Okay, so ngayon class, sa pag-sip ng tubig, no, from, let's say, from point B to point A, class, magkakaroon ng head loss, no, kasi dumaan yung tubig dun sa soil, no, so magkakaroon ng head loss. So yung magiging head loss between point A at point B will be the difference, class, nung head, okay, nung, ano natin, nung water natin sa point B, which is ito yung head niya, hanggang dito, tapos yung head naman nung point A natin, class, ay hanggang dito. So, yung difference nung dalawang heads na yun, class, that will be the head loss, no, between A at B. No? So, yung head loss na yun, class, is yung H. Okay, ngayon, class, ganito. Kapag dumaan din, class, yung tubig, let's say from point C, papunta dun sa point A, magkakaroon din ng head loss. So, yung magiging head loss niya, class, will be the difference nung head nung water dito sa point C, which is ito yon. Okay, at saka yung head ng water dito sa point A, which is ito yon, no? So, ito yung difference nila, class. So, para ma-compute natin, class, yung head loss na ito, class, okay, para ma-compute natin yan, class, pwede mong gamitan yan ng proportion. So, that will be H, yan yung head loss between A at B, okay, over yung distance between A and B, class, yung height between A and B ay H sub 2, so H over H sub 2. So, equate mo lang yan, class, dun sa head loss between A at C. Ang head loss between A at C, class, ay let's say H sub C over yung height or distance between A at C. So that will be Z. So that's why it's over Z. So, kung ang kukunin mo is yung headless between A at C, that is H sub C, that will just be H sub C is equal to H over H sub 2 times Z. Kaya ito yung class, yung H over H sub 2 times Z. So, ito ngayon yung head loss between point A and point C. Alright. Alright, so from here, class, let us determine the total stress, pore water pressure, and effective stress, no, at different points dito sa figure natin, no. So, class, keep in mind that the total stress at any point in the soil mass is due solely to the weight of soil and water above it. So, mag-start tayo, class, dito sa point A. Alright, so at point A, para dun sa total stress natin, it will just be the soil or the water above point A. So, in this case, water lang naman yan. No, so it will just be H sub 1 times yung unit weight ng water. Okay, so that will be H sub 1 times gamma water. That will be the total stress at A. For the total stress naman, or ano muna, no, pore water pressure muna at point A. Para sa pore water pressure at point A, so it will just be the same, no? H sub 1 times gamma water. Alright, now for the effective stress at point A, so difference lang yan ng total stress at pore water pressure, so that will be 0. Alright, now at point B, point B ba muna? Okay, dito muna tayo sa point B. Para sa point B, class, ang total stress natin dito, class, will be itong binibitbit niya na tubig at saka itong binibitbit niya na soil, no? So that will be H sub 1 times gamma water para dun sa tubig plus H sub 2 yung height ng soil, no, times gamma sat. So saturated itong soil na ito, ha. So yung saturated unit weight nung soil na ito. Alright, so that will be the total stress at point B. Now, para dun sa pore water pressure at point B, so class, ang tingnan mo dito ay ito, ha. So this will be the height, no, kung saan yan yung gagamitin mo sa computation ng pore water pressure natin. So, yung height na ito, class, this is H sub 1 plus H sub 2, tapos i-add pa natin tong H. So that will be the total height dito sa ano natin, sa piezometer natin. So that will be the height na kailangan natin, ha, sa pag-compute ng pore water pressure dito sa point B. Alright, so that will be H sub 1 plus H sub 2 plus H times gamma water. Now for the effective stress at point B, again, difference lang yan ng total stress at pore water pressure. Alright, so substitute natin yung total stress natin, ito yon, so ito yon. Okay, tapos yung pore water pressure natin, ito yun, no? So, substitute mo lang, minus ito. Alright. So, class, pag sinimplify mo to, i-distribute mo. Okay, so what happens, class, is H sub 1 times gamma water minus H sub 1 times gamma water, makakancel yon. Tapos, H sub 2 gamma sat, pwede nating i-factor out yung H sub 2 niyan, tsaka H sub 2 dito, tsaka ito, i-distribute mo kasi yan. So, ang mangyari, H sub 2 times gamma sat minus gamma water. And then minus H times gamma water. Alright, so simplify mo pa ito, class. So, simplifying this, itong gamma sat minus gamma water, class, yan ay effective dry unit weight. So, yan ay gamma prime. Tama. Alright, so class, ito na, class, yung effective stress at point B, no? Now, dito na tayo sa point C. So, for point C, mag-start tayo dun sa total stress. Para dun sa total stress, that will just be the weight ng soil at saka ng water above point C. So, para dun sa tubig, that will just be H sub 1 times gamma water plus, ito, this is Z times yung saturated, no? Unit weight na saturated. Ito yun, class. Okay, so that will be the total stress at point C. Now, for the pore water pressure. So, dito sa point C, class, again, titingin ka sa height nung piezometer na naka-attach dyan sa point na yan. No? So, yung height niya, class, ay ito. So, ito ay Z plus H sub 1. Tapos, yung height na ito, class, na banggit na natin yan ay H over H sub 2 times Z, no? So, yan na, class, yung height times yung gamma water. Alright, so this is the pore water pressure, class, for point C or at point C. Now, for the effective stress at point C, so subtract lang natin yung total stress at saka pore water pressure. So, for the total stress, ito yon. So, nire-write lang natin. Minus yung pore water pressure, ito yon. So, ito yon. Okay, so kapag sinimplify natin ito, class, so distribute natin ito doon sa gamma water. So, yung H sub 1 gamma water, makakancel siya kasi this will become H1 gamma water minus H1 gamma water, makakancel yun. No? And then, yung Z naman, class, pwede nating i-factor out Z gamma sat, tapos ito Z gamma water. So, factoring out Z, that will become gamma sat minus gamma water. Minus yung natira, H over H sub 2 times Z times gamma water. Alright, so pwede pa natin ito masimplify yung gamma sat minus gamma water, that is effective unit weight, gamma prime. Alright, so simplifying this further, class, itong H over H sub 2, take note class na yan ay hydraulic gradient I. Tama kasi yung H yan ay head loss, no, between point A at point B. Tapos yung H sub 2 naman class, yan yung, kumbaga, distance between point A at point B. So, definition natin yan, no, ng hydraulic gradient dun sa discussion natin about permeability of soil, no. So, head loss over yung excuse me, yung length, tama, nung dinaanan ng tubig class, yun ay hydraulic gradient, no. So, pwede nating palitan class yung H over H sub 2 ng hydraulic gradient I, no? So, pwede natin siyang i-rewrite this way. So, this will become effective stress at C is equal to Z gamma prime minus IZ gamma W. So, ito class ay equation, anong equation ito? Equation 9.7, no? So, tandaan mo yan. This is our equation 9.7. Alright. Alright, so if we're going to plot the computed stresses, no, at points A, B, and C, so ito yung kakalabasan niya class. So para dun sa total stress, no, sa point A natin, ito yung point A natin, or dito na lang, dito tayo magsimula. So dito sa point na to, 0 naman yan, no. Sa point A class, yan ay H sub 1 yung depth dyan. Okay, so H1 gamma water yung total stress natin. Dito naman sa point C, dito sa point C, ano ba yan? H1 gamma water, ito yun, no? So, ito yun, H1 gamma water plus Z gamma sat. Para naman dun sa point B, ito yung point B natin. So, yan naman ay H sub 1 times gamma water plus H sub 2 gamma sat. Ito naman yan. Na, so, kapag pinlat mo yan, class, no, connect mo lang by a straight line from point to point. And then, para naman dun sa pore water pressure, at this point naman, 0 yan. Tapos, sa point A, H1 gamma water. Dito sa point C, ito, no? Point C, H sub 1 plus Z plus H over H sub 2, Z gamma water. So, I na to, no? Ginawa na natin itong I, yung H over H sub 2. Tapos, sa point C, or point B naman, class, yan ay H sub 1 plus H sub 2 plus H times gamma water. So, andito siya, no? So, connect mo lang ng straight line from point to point. And then, sa effective stress natin, class, so, 0 siya sa point na to. Dito rin sa A, actually, 0 siya. Sa C naman, class, yan ay Z gamma prime minus IZ gamma water. And then, dito naman sa point B, class, H sub 2 times gamma prime minus H times gamma water. So, ito na class yung plot, no, nung variations ng total stress for water pressure, effective stress natin at points A, B, and C. Alright. Alright, so if we are going to compare the effective stress here na merong upward seepage at saka yung effective stress class kapag walang seepage, ito yung plot nung ano natin class, nung stresses natin ha, dun sa with no seepage. Na ito naman with upward seepage. So, mapapansin natin, class, na let's say dito sa depth na, dito sa point C. Okay, so ito class yung effective stress natin kapag may upward seepage. Ito naman sa point C, class, ito yung effective stress, no, with no seepage. Ito naman, no. So, mapapansin mo, class, na nagkaroon ng reduction doon sa effective stress natin from Z gamma prime naging Z gamma prime minus IZ gamma water. So, nagkaroon ng reduction na IZ gamma water dito sa effective stress natin, class, no? Dahil nga meron tayong upward seepage. Alright. Alright, so let's talk about what we call boiling or quick condition. So, class, kapag yung rate of seepage natin, class, ay in-increase natin, ang nangyayari, class, nai-increase din yung hydraulic gradient. And in that case, class, ang nangyayari is, nare-reach, class, yung limiting condition natin. So, yung limiting condition natin, class, is kapag yung effective stress ay nag-zero. Okay, so, class, let's say dito sa point C. No, so, class, kapag itinaas natin, class, yung rate of seepage at nag-zero yung effective stress dito sa C. So, let's say gamitin natin, class, yung nakuha natin na equation for effective stress at C kanina, ito yun. Alright? So, class, kapag nag-zero yan, ang mangyayari, yung hydraulic gradient natin, it will become critical. Okay, yung I natin, it will become I sub CR, no? So, yung I sub CR yan ay critical hydraulic gradient at nangyayari nga yan, class, kapag yung effective stress natin, class, ay nagiging 0. Alright? So, class, yung condition na yan, class, no? Ang nangyayari, yung soil stability is nawawala. Soil stability is lost. So, yung soil stability, class, kung i-define natin yan, yan yung capability ng soil particles to maintain their bands under stresses. So, ibig sabihin, kapag nawala yung soil stability, class, yung bands, class, nung soil particles natin, nawawala yun. So, ang nangyayari, yung soil particles natin nagmo-move. Okay, so yung situation na yun, class, generally is referred to as boiling or aqueous condition. So, class, mula dun sa equation 9.8 natin, class, ito yon. So, kapag kinuha natin yung hydraulic gradient na critical dyan, ito yon, yung I sub CR. So, i-transpose lang natin ito. Tapos, yung Z makakancel, no? So, what happens kapag sinolve mo yung I sub CR, that will be gamma prime over gamma water. Tama? So, ito ngayon, class, yung pagkuha natin, nung tinatawag natin na critical hydraulic gradient. So, for most soil, the value of the critical hydraulic gradient varies from 0.9 to 1.1 with an average of 1. Alright. Alright, let's try to solve sample problem here. The figure shows a layer of granular soil in a tank with an upward seepage by applying water through the valve at the bottom of the tank. The loss of head caused by upward seepage between the levels of A and B is 0.70 meters. The void ratio of the soil is 0.52 and its specific gravity is 2.72. Okay, so ito, class, yung tank natin na merong layer of granular soil, no, na merong upward seepage. So, dito manggagaling, class, yung upward seepage kapag inopen itong valve na ito. Okay, so, class, yung head loss daw, okay, between point A, ito yun, at point B, yung head loss nila, class, so, yung head kasi nung A natin andito, yung head nung B natin nandito. So, yung head loss daw nila, class, between A at B, class, ay 0.70 meters. No? Tapos, binigay din, class, yung void ratio ng soil, 0.52. Tapos, yung specific gravity binigay din. No? So, sa letter A, class, ang pinapakompute sa atin dito is yung effective stress at C. Nasaan ba yung C? So, yung point C ay nandito. Yan ay 2 meters below point A. No? So, yung effective stress dito sa point na to yung pinapahanap, ha? So, class, para ma-determine natin, class, yung effective stress at C, so, i-determine muna natin yung total stress at saka yung pore water pressure sa C. So, mag-start tayo dun sa total stress. So, class, before mo ma-solve yung total stress, no, kailangan mo, class, i-solve yung saturated unit weight ng soil natin kasi hindi siya binigay, yung saturated unit weight. Pero may mga binigay na property ng soil, no, na void ratio at saka specific gravity. So, pwede nating ma-solve, class, yung saturated unit weight ng soil natin by using our derived formula for saturated unit weight. That will just be G sub S plus E times gamma water over 1 plus E. No? So, solve muna natin yung gamma sat. Ito yun, yung formula natin. Alright, yung G sub S natin, 2.72. Yung E natin, 0.52. Yung gamma water natin, ano bang unit natin? 9.81 kilonewton per meter cube. So, i-substitute lang natin dito, class. At ano yung lalabas, class? So, i-compute natin yan sa calculator natin. Alright, so 1 plus, and ang lalabas dyan, class, ay 20.91 kilonewton per meter cube. So, that will be the saturated unit weight ng soil natin. Ano pa bang kailangan natin, class? Okay, so, para dun sa total stress, masosolve na natin yan, tama? Pero dun sa pore water pressure pala, class, no? So, siguro i-solve na rin natin, class, yung kailangan natin para dun sa pore water pressure. Ang kailangan natin doon, yung height ng tubig, no? Nung, dun sa piezometer na naka-attach dito sa point C. So, yung height ng tubig niya ay ito, no? So, ito, class, ay 2 plus 1 plus itong height na to. So, alamin natin ano tong height na to. Itong height na to, class, ito yung head loss between point A at point C. So, let's say H sub C yan. So, class, para ma-solve natin yan, yung katulad lang ng ginagawa natin, i-proportion mo lang, class, ratio and proportion. So, that will just be 0.70, yan yung head loss between A at B, over yung distance ng A at B, which is 2 plus 3, that will be 5. So, equal dun sa head loss na hinanap natin, which is ito, H sub C, over yung distance between, between kung saan mo kinuha yung head loss, yeah, that is between point A at C, so that is 2 meters, no? Okay, so solving for H sub C class, ang lalabas dyan ay 0.28 meters. So this time class, pwede na tayo mag-start na isolve siguro yung ano muna, total stress. So para dun sa total stress at point C, so that will just be the height ng tubig. Okay, so that would be 1 times 9.81 yung unit weight ng water plus yung ito naman, yung soil, yung saturated soil. That will be 2 meters times yung unit weight or saturated unit weight na na-compute natin, which is 20.91. So, ang lalabas dito, class, ay, okay, compute natin. Ayan, ang lalabas, class, ay 51.63, no? Alright, so yan na ngayon, class, yung total stress at point C. So, kailangan pa natin isolve yung pore water pressure at point C. So, that will just be yung height nung tubig, that will be 1 plus 2. Ito yon yung 2 plus 1 plus yung H sub C. So, that will be 2 plus 1 plus yung H sub C natin ay 0.28 times yung gamma lang ng water, which is 9.81. At ang lalabas dyan, class, ay... Alright, ang lalabas dyan, class, ay 32.18 kilopascal, no, or kilonewton per meter squared. Alright, so this time, class, pwede na nating makompute yung pinapahanap na effective stress at C. So, subtract lang natin yung total stress at pore water pressure. Okay, so ang kakalabasan nito, class, 51.63 minus 32.18, that will be 19.45. So, ito na, class, yung effective stress at C, 19.45 kilopascal. Alright. Alright, for letter B, we are asked, class, to determine the critical hydraulic gradient. So, to determine the critical hydraulic gradient, let's just use yung formula natin, that is critical hydraulic gradient or I sub CR is equal to gamma prime over gamma water. Wherein yung gamma prime, yan, class, ay effective unit weight lang. Tapos yung gamma water is the unit weight of water, no? So, class, para dun sa effective unit weight, that is just gamma sat ng soil minus gamma water over gamma water. No? So, yung gamma sat natin, na-solve naman na natin kanina. So, that will just be 20.91 minus yung gamma water natin, 9.81 over 9.81. At ang magiging sagot dito, class, ay... Alright, ayan. So, ang kakalabasan dito, class, ay 1.13. So, yan na yung hinahanap natin, class, na critical hydraulic gradient. Alright. For sample problem number 2, a 9-meter thick layer of stiff saturated clay is underlain by a layer of sand. So, ito yung 9-meter thick saturated clay natin. Okay, and then it is underlain by a layer of sand. So, ito yung layer of sand na binabanggit, no? Alright, so, class, sabi dito, the sand is under artesian pressure. So, ibig sabihin, class, subjected yung sand natin, class, na ito sa ilalim by an upward seepage. No? And as you can see, kapag naglagay ka ng piezometer dito sa sand layer natin, class, no, magkakaroon ng pagtaas ng tubig dito, no, at 3.6 meter. Kasi nga, class, subjected siya, class, sa upward seepage. No? Ngayon, class, ang pinapakalculate sa atin dito, class, is yung maximum depth of cut H that can be made in the clay. So, what if daw magka-cut tayo ng, kumbaga, depth of, let's say, cut H nga, no? So, ito yung, kumbaga, i-excavate, no? Na yung height niya, class, ay H. So, ano daw yung maximum, class, na height na pwedeng i-excavate in such a way, class, na mare-retain yung stability ng soil. Okay, so take note, class, ha, itong sand kasi natin, class, no, na nasa ilalim, subjected siya to upward seepage. So, kapag tinapyas natin, class, itong buo na ito, class, hanggang dito sa point na ito, class, no, magiging ano na, magiging unstable na yung soil natin, no. So, class, dito makita natin na yung point A, this will be the most critical point. Okay, so kung i-consider natin, class, yung stability ng point A natin, class, so yung magiging total stress natin dito sa point A natin, class, ay itong 9, no? Tapos minus itong H times yung saturated unit weight ng clay, which is 18 kilonewton per meter cube, no? So that will be the total stress. So kung may imagine mo, class, originally, class, merong, kumbaga, kine-carry itong point A natin na clay hanggang dito. Tama? So, originally 9 times 18 yun, pero nabawasan class nung height h, no? So, ang nangyari doon class, magkakaroon ng unloading ng overburden pressure. Alright, so, ngayon class, para dun sa pore water pressure naman dito sa point A, so, class, ano mo lang dito, yung reading natin class dito sa piezometer, no? At point A, dito yon. So, 3.6 meters yan. Okay, so 3.6 meters times, ano lang yan class, unit weight ng water. So, ito yung pore water pressure at point A. So, 3.6 times 9.81. So, this time, para malaman natin yung maximum na H, no, na pwedeng ikat class, we have to set yung effective stress dito sa point A natin to 0. Okay, para ma-compute natin class yung maximum na pwedeng ikat. So, iset natin class yung effective stress at A to 0. So, ang mangyayari dito class, ito yung effective stress natin, total stress lang yan, minus pore water pressure. Tama? So, 0 na class yung effective stress at A natin, kailangan natin siyang iset sa 0. And then, itong total stress natin at A ay 9 minus H times 18 minus yung pore water pressure natin ay 3.6 times 9.81. No? So, class, ang unknown lang dito is yung H. No? So, we can solve for H at ang lalabas class na H dito class ay, alright, ang lalabas dyan class ay 7.038 meters. So, ito na class yung hinahanap natin na cut H, no, na pwede class, no, na hindi matatanggal, no, or hindi mawawala yung stability ng soil natin. So, yan na yung sagot class. Alright. For sample problem number 3, a cut is made in a stiff saturated clay that is underlain by a layer of sand. What should be the height of the water H in the cut so that the stability of the saturated clay is not lost? Alright, so class, this is similar dun sa sample problem number 2 natin. Ang kaibahan lang dito, ang hinahanap dito is yung height ng water na kailangan dito, no? Kasi yung cut natin, class, ibinigay na siya. Okay, yung height ng cut natin, which is 5 meters. Ngayon, ang tanong, ano yung height ng tubig na kailangan natin dito, class, in such a way na yung stability ng saturated clay natin is hindi mawawala. So, what we're going to do here, class, ang magiging critical point natin, so point A pa din yan. Okay, so alamin natin, class, yung magiging total stress at saka pore water pressure dito, class, no, dito sa point A. Para dun sa total stress natin, so it will just be kung ano yung kinikerry niya na soil at saka tubig. So in this case, class, ang kinikerry niya na soil at tubig, or dun muna sa soil, ito yon. So ang height na ito, class, is just 7 minus 5. Tama, times yung saturated unit weight nitong saturated clay na to, which is 19. So this will be 7 minus 5 times 19, no? Para dito sa binibit-bit niya, class, na saturated clay. Para naman dito sa binibit-bit niya, class, na tubig, so it will be H, okay, times yung unit weight ng water, which is 9.81. So, para dun sa total stress dito sa A, it will be 38 plus 9.81 H. Now, for the pore water pressure at A, class, ang titingnan mo na height dito is yung height dito, class, sa piezometer natin. Ha? So, class, para sa pore water pressure at point A, so the height is 4.5 and then yung unit weight ng water natin 9.81. So, yung magiging pore water pressure natin ay 44.145 kilonewton per meter squared. Ngayon, class, para ma-determine natin yung height of water, ito yon, yung height H na to, class, no, na kailangan in such a way na hindi mawawala yung stability nung saturated clay natin. So, class, kailangan nating iset sa 0 yung effective stress dito sa point A. So, iset natin, class, yung effective stress as 0. So, yung mangyayari dito, 0 yung effective stress natin. Yung total stress natin, ito yon. Okay, ito yon. Tapos, minus yung pore water pressure natin, ito yon. So, yung magiging unknown lang dito, class, is yung H natin. No? So, solving for H, class, ang lalabas ay, anong lalabas? Ang lalabas dito na height, class, ay 0.626 meters. So, ito, class, yung hinahanap natin na height H, no, nung water natin. Alright. We are now done with the stresses in saturated soil with upward seepage. So, we're now going to proceed to the stresses in saturated soil with downward seepage. So, itong figure natin ngayon, class, figure 9.7a, no? So, it shows, class, the condition of a downward seepage. Alright? So, ito, class, yung, ano, no? Kumbaga, sa taas na galing yung tubig. Okay, instead na dito sa baba, no? So, dito class manggagaling yung seepage sa taas. Okay, so the water level in the soil tank is held constant by adjusting the supply from the top and the outflow at the bottom. So, yung mangyayari dito class, kung downward yung seepage natin class, no, kapag naglagay tayo class ng piezometers dito class, so dito sa point A natin class, yung magiging ano lang dito class, pagtaas ng tubig is just ka-level nito. No, pero pagdating let's say dito sa point C, kapag naglagay tayo ng piezometer dito class, since downward yung seepage natin class, yung mangyayari class dito sa piezometer natin is ano siya, a little lower siya, no, kesa dito sa ano sa water surface natin dito. No, so bababa siya. Okay, ganun din class dito sa point B natin class kapag naglagay ka ng piezometer dyan. So, yung height ng water dyan, yan yung may pinakamababa na height no, doon sa mga piezometers natin. So, class yung difference or yung head loss natin class between point A at saka point B class will just be the difference nung head sa point A which is ito, tsaka yung head sa point B which is ito. So, ito class yung head loss ha between A at B, that is H. Okay, ngayon, para dun class sa head loss between point A at saka point C, okay, so that will just be the difference nung head dito sa point A at saka yung head dito sa point C. So, class kung alam natin yung elevation ng point C which is Z below point A, so pwede nating malaman class yung head loss na yan class no, between point A at C. So, that will just be H over H sub 2 times Z. No? So, proportion lang yung ginamit natin dyan, katulad dun sa downward or upward seepage natin kanina. Alright. Alright, so the hydraulic gradient caused by the downward seepage equals I is equal to H over H sub 2. So, same lang din yan dun sa may upward seepage natin kanina. No? So, class, the total stress, pore water pressure, and effective stress at any point C are respectively. No? So, ito class yung, let's say, total stress dun sa point C. Ito yung point C natin. So, it will just be ito, yung soil na kinikerry niya, which is Z times gamma sat, no? At saka yung H sub 1 tapos yung times yung unit weight ng water. Alright, para naman class dun sa, let's say, pore water pressure niya class, so dito ka titingin sa height dito. So, yung height na ito class ay H sub 1 plus Z minus, ito no, itong height na to, ito yon. Okay, so yan ay H over H sub 2 times Z. No? So yung H over H sub 2 yan ay I, no? So pwede natin palitan times yung unit weight ng water. So para dun sa effective stress class, difference lang yan nitong total stress at pore water pressure natin. So itong total stress, ito yon, minus yung pore water pressure natin, ito yon. So class, para dun sa effective stress natin class dito sa point C, no, kapag sinimplify na natin class, ito na yung kakalabasan niya. So ito class ay effective stress sa C is equal to Z times gamma prime plus IZ gamma W. So mapapansin mo class, kung kanina dun sa upward seepage, di ba minus ito? Tama, minus IZ gamma water yan. Pagdating dito, plus na yan. No? Kasi nga class, sa downward seepage class, ang ginagawa niya, ini-increase niya yung effective stress. While sa upward seepage naman, dinidecrease niya, no, yung effective stress natin. Alright, so class, kung i-graph natin or ipa-plot natin yung mga stresses natin at different points, ito class yung kakalabasan. Okay, so same lang din naman ito ng pagpa-plot natin with seepage, without seepage, with upward seepage. So, yan lang din naman yung ginagawa natin dyan class. No? Kunin mo lang class yung total stress at point A, point C at saka point B, yung pore water pressure sa point A, point C, point B, tapos yung effective stress, no? So, ito class yung variation, no, nung total stress, pore water pressure, and effective stress with depth also, no? So, shown siya dito. Alright. Alright, for sample problem number 1, the figure shows a granular soil in a tank having a downward seepage. The water level in the tank is held constant by adjusting the supply from the top and the outflow at the bottom. Void ratio of soil is 0.47. Specific gravity is 2.68. So, for letter A, we are asked here to compute the effective stress at point C. Yung point C natin ay nandito. So, yan ay 4 meters below point A. Alright, so, class, para ma-solve natin yung effective stress dito sa C, kailangan nating isolve yung total stress, Wherein dun sa total stress class, kakailanganin natin class yung saturated unit weight nitong soil na binibitbit nitong point C or above point C, no? So class, yung soil natin na ito class, binigay naman yung property niya na void ratio tsaka specific gravity. So we can solve the saturated unit weight, no, nitong soil natin. So i-compute muna natin since hindi kasi siya given yung saturated unit weight. So i-compute natin yung saturated unit weight ng soil natin. So this is the formula. Substitute lang natin yung G sub S natin tsaka yung E. Alright, so ang kakalabasan nito class ay 21.02 kilonewton per meter cube. Now, para dun sa pore water pressure sa sea, kakailanganin din natin class yung head natin, no, para dito sa sea. Para sa head natin sa sea, ito kasi yung kailangan natin. No? So, kailangan natin class itong difference ng head ng A at saka ng C. So, pangalanan natin na H sub C yan, no? So, para ma-solve natin yan, class, pwede tayong gumamit ng proportion. Gamitin natin, class, yung difference, okay? Or gamitin natin, class, yung head loss between point A at point B. Ang head loss nila, class, ay 0.90 over yung distance, no, or yung height between A at B. Yan, class, ay 6 meters. So, 0.90 over 6 equal siya, class, doon sa hinahanap natin na head difference, which is H sub C. Okay, over, so yung difference na class between A at C, no? So ang distance natin between A at C ay 4, no? So we can solve for H sub C class, so yan ay 0.60 meters. Alright, so we can now solve class yung total stress natin para dun sa total stress natin dito sa point C. So that will just be 4 meters times yung unit weight or saturated unit weight nitong soil na ito class, which is yung na-compute natin kanina, 21.02. Ito yon 4 times 21.02. And then yung tubig naman class, 1 meter ito times yung unit weight ng water, which is 9.81. No? So ito yung total stress natin, 93.89 kilonewton per meter squared or kilopascal. Now, para dun sa pore water pressure dito sa point C, so yung height na gagamitin natin class will be this height, no? So para makuha natin tong height na to, so this is just 4 meters plus 1, tapos subtract natin yung H sub C para makuha natin tong height na to, no? So ulitin ko, 1 plus 4 minus H sub C class, yun yung height na to. Okay, wherein yung H sub C natin class ay 0.60 meters. So, times 9.81 lang yon na unit weight ng water. So, makukuha na natin yung pore water pressure sa sea. So, ang lalabas dito class ay 43.16 kilopascal. Para dun sa effective stress at sea, subtract mo lang class yung total stress, tapos pore water pressure natin. So, that will just be 93.89 minus 43.16. Ang lalabas na effective stress at point C class ay 50.73 kilopascal. So, this is already the answer for letter A. Alright. Now, for letter B, we are asked to solve the effective stress at point B. So, our point B is here. Alright, so solve muna natin class yung total stress natin. So, it will be etong height nung soil natin, which is 6 meters, times yung saturated unit weight natin na na-compute, plus 1 times yung gamma ng water. No? So, that will be, ito ngayon, ito yung para sa tubig, ito yung para dito sa 6 meters na soil natin. No? So, yung saturated unit weight natin, ito yung na-compute natin pa rin kanina ha, na 21.02. Alright, so yung total stress natin at point B ay 135.93 kilopascal. Okay, ngayon para doon sa pore water pressure natin dito sa point B, so kakailanganin natin yung height dito sa piezometer natin na naka-attach dito sa point B. So ang height na ito class, we can solve this by dito, no? So 1 plus 6, tapos subtract natin yung 0.90 para makuha natin tong height na to, no? So that will be 9.81 yung unit weight ng water. So 1 plus 6 minus yung ito yung 0.19, no? So, class, ang makukuha natin dito, class, na pore water pressure ay 59.84 kilopascal. So, solving for the effective stress, so that will just be the total stress minus the pore water pressure. So, it will just be 135.93 minus 59.84. Okay, so ang lalabas dito, class, ay 76.09 kilopascal. So, this is now the effective stress at point B. Alright. That ends our discussion for this video. Thank you for watching. God bless.